All right, today we're going to talk about angles of rotation, coterminal angles, and arc length. And since this is the first unit of trig, we need to discuss and go back in time and talk about what an angle actually is. Okay, and I think everybody, if they were asked to draw an angle on their piece of paper, they would come up with something maybe that looks a little bit like this. And a lot of people would draw this because the angle is actually the space in between here. And this point right here, if we do some vocabulary, this is the vertex. And it's in an angle, basically, is a union of two rays. And they are brought together by the vertex here. Okay? And union means, obviously they are two together here. So what we're going to do is take our knowledge and understanding of angles, and we are going to put them with our knowledge of algebra, algebra 2, and pre-calculus, and we're going to put them on the XY plane. So I'm going to draw an XY plane. That's the coordinate set of axes here. And we call this quadrant 1, this quadrant 2 over here, this quadrant 3, and we use Roman numerals to describe that. And this is quadrant 4. Okay, and I'm going to take an angle like this, and I'm going to put it on the XY plane. Okay, so let's do that. And I think I'll use green. So here I'm going to put I call the initial side on the positive x-axis. And I'm going to draw a terminal side over here. And then I'm going to show a direction of rotation. Okay, and so we're going to call this an angle in standard position. An angle in standard position has the following qualities. First of all, we put the vertex at the origin. And you see how we have the vertex of our angle here at the origin. That's number one. Number two, we put the initial side on the positive x-axis. Oops, I can't spell axis today. Let's try better. There we go, on the positive x-axis. Okay, so we have our initial side on the positive x-axis, and our terminal side we, put wherever our angle ends. And then we have a direction. We show direction with our arrow, our direction arrow. Okay, now this right here we call the initial side, as I indicated. And this side is our terminal side, meaning that's where our angle stops. Okay, now I could have chosen to rotate my angle this direction, and that would have been a much different angle, okay? But this angle I rotated counterclockwise because the hands on a clock go this way. We call that direction clockwise, and counterclockwise would be the opposite direction of the clock. So this angle is rotating counterclockwise. And for our definition of angles, we're going to say counterclockwise rotation Okay, we're going to call that a positive angle. And my abbreviation for counterclockwise is going to be CCW, counterclockwise. Okay? And we're designating this direction counterclockwise as a positive rotation. And I believe the reason through time we've called these positive rotations is if you notice that the quadrants go in a positive direction when you're counting 1, quadrant 2, quadrant 3, quadrant 4. So this is naturally, positive, even though it might not feel like we're going in a positive direction, okay? All right, so then if counterclockwise rotation is considered a positive angle, clockwise rotation or just clockwise is considered negative rotation. And again, it doesn't mean the angle's negative or positive. It just the negative and the positive applies to which direction you're rotating. Okay. Now, the angle that I've drawn here, I call this angle, this is a quadrant 2 angle. And it's a quadrant 2 angle because its terminal side ends in quadrant 2. If I had my terminal side in quadrant 3, it would be quadrant 3 angle. If I had my terminal side ending in quadrant 4, it'd be quadrant 4 angle. And obviously in quadrant 1, it'd be quadrant 1 angle. Okay? But I ask you this question. What if I land on, let's say I have an angle of 90 degrees, right? And I end up on, and I'll draw a picture of that here. What if my angle of rotation, if I decide to do this, is this angle, and this is clearly 90 degrees. Well, which quadrant is that? It's like an angle lost between two quadrants. So we have to have a different name for these because I can't say it's a quadrant 1 / quadrant 2 angle. We call these quadrantal angles, okay? So angles that terminate on the X or Y axis are called quadrantal angles. And it's just quadrant with an AL at the end. Okay, so that's just a definition. And we have many different quadrantal angles, right? So I said this was 90 degrees here. That's a quadrantal angle. What about this angle here? If I said, all right, well, what about this angle? Well, now I'm rotating clockwise, so this would be negative 270, this red one. Okay. Now, I just drew an interesting picture, okay? I drew a picture of some angles here that share the same terminal side. You see how this 90-degree angle side is on the y-axis here, and this negative 270 degrees has the same terminal side? Well, they share the same terminal side, and if you had 3 points in geometry that were on the same line, you'd call them collinear. And if you had 2 lines on the same plane in geometry, you would call them coplanar. And so if you have 2 angles that share the same terminal side, you'd call them coterminal. Okay, so by definition, here's another definition. Coterminal angles so I'll underline that as a definition, are angles that share the same terminal side. So a lot of vocabulary here, but you know what? We'll use these so often that you'll get more and more familiar with them. Okay. So we've got quadrantal angles. We have coterminal angles. Now, what happens? You know, if I have an angle that's 720 degrees. Let's say I have my angle theta, and I say I want that to be 720 degrees. If I were to graph that, here it is, my XY plane. And I'm going to go counterclockwise. So there's my initial side, because I'm going to put it in standard position. 720. Well, all the way around is a 360. And 360 times 2 is 720. So if I were going to go all the way around, here it is, I'm going in the positive direction, that's 360 degrees. And then if I'm going to show the direction and my angle of rotation, I'm going to go around one more time. And that's 720. So we can go around multiple times to show our angle of rotation. Okay? So let's do some practice. All right, here we go. We're going to draw the angles of rotation. Okay, we're going to classify each angle by quadrant. And if the angle is quadrantal, we're going to say it's quadrantal. We're going to state a positive coterminal angle and a negative coterminal angle. And I'm going to come up with an expression, because we can have infinitely many coterminal angles if you think about it. So let's start off in a negative 160 degrees. And we're going to put these in standard position because that's what the question requires. Okay, so standard position means my initial side is on the positive x-axis. All right, and so I'm going to go negative 160 degrees, which means I'm rotating clockwise, but I'm not going to get to 180. I'm going to be 20 degrees short. So here we go. Here's my terminal side. And this is obviously an approximation. We're not using a protractor to figure out what the angles are, but here's my rotation. Okay. And I would say that this is a what quadrant angle? Well, this is a quadrant 3 angle because its terminal side is in quadrant 3. And if I want a positive coterminal, and I want another negative coterminal, and I want an expression for all of the coterminals, you'll see what I mean in just a minute. Okay, so here we go. Well, a positive coterminal, remember, a coterminal means that I'm sharing the same terminal side. Okay, so I could draw the positive rotation, which is counterclockwise, and go from the positive or initial side here and rotate this direction, right? So if I rotate this direction, I will have gone 180 plus 20, which is 200. So that would be 200 degrees, right? And if I were to draw that, you would see that it is going this direction. Okay, now a negative coterminal means it has to go clockwise but end up in the same spot. So if I'm ending in here, I'm going to have to go all the way around and then hit it again. Okay, so how do I figure that out? Well, I know that 360 degrees is all the way around. So if I'm going to go all the way around again, I'm going to go negative 160 minus 360, right? Because that's what's going to get me the next go round, and that would be negative 520 degrees. Because I will have gone negative 360 plus 100, negative 160, which gets me at negative 520. But I could keep going around, right? I mean, I could, you know, create another coterminal angle in the negative direction by going all the way around one more time, and then stopping at another one. You see, so I could keep doing this infinitely many times, and there are infinitely many coterminal angles. So how could we write an expression that represents all the coterminal angles? Well, what I like to do is start with the initial angle. Okay, so negative 160 degrees plus, how do I get to the next coterminal? Well, I can continue to add 360 or subtract 360, increments of 360, and I could use a variable called n that represents the number of times that I'm going to go around the circle. Okay? But I have to define what n is, because I don't want n to be 1/2, because I'm not going to go halfway around the circle, or 1/4. So I have to define n as a specific number. And so I need n to be an integer, and there's an expression for that. We would say n, an element, using the epsilon, and then the fancy z here. Now we're all used to the real numbers. The set of real numbers represented by this fancy r. Well, I'm going to tell you that the integers are represented by a fancy z. Okay, now integers are all the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, and 0. And then the integers include all of the negative numbers, so negative 1, negative 2, negative 3. So this n is an element of the integers. Okay, so this representation takes care of any time I want to go around the circle to hit another coterminal. Now, a lot of students ask me, well, Mrs. Muller, why don't I do plus or minus here? Well, because I've defined n as an integer. So if n is an integer, it's either plus or minus. So this integer representation here takes care of this plus or minus. Okay? All right, so let's keep going. Negative 650. We're going to go negative. All right, so here we go, negative 650. So we're going to start in standard position, the initial side on the positive x-axis. And I'm going to go around, let's see, how many times? Well, 360 is all the way around once. So we're going to go negative 360. And then I have to go, if I go all the way around again, that'll be 720. But how short am I from 720? So if I subtract 650 and 720, so 720 minus 650, I get 70. So I'm going to be 70 short of 720. So I'm going to be 70 short, which is about 30 degrees here. So I'm going to go all the way around almost, and then leave 70 off. So I will have gone 360 plus 70 short of another 360, if that makes sense. Okay. All right, so let's discuss what this one is. This is a quadrant one angle, because my terminal side is in quadrant one. Okay, so let's do a positive coterminal, negative coterminal, and an expression for all of them. And I'm going to abbreviate for coterminal here, okay? So here we go. A positive coterminal. Remember, coterminal means it shares the same terminal side. Well, I'm going to go the easy route and suggest to you that this angle right here could be a coterminal if I start here and rotate counterclockwise, right? So that would be 70 degrees. That's a positive coterminal. Now, if I wanted to know a negative coterminal, I could start here and rotate all the way around to here, right? If I don't rotate all the way around. So this 70, let's see, is going to be like this so we can see it. You see how that's going to share the same side? Same terminal side? All right, now, if I wanted to share the same terminal side, instead of going around more than once, I could just go around part way and be 70 short of 360. So that would be negative 290 degrees. All right. And now how do I write an expression for all the coterminals? Well, I'm going to start with the angle I was given, negative 650 degrees, plus 360 times n, an element of the integer set. And this takes this around the circle n times if n is an integer. So that'll give us all of the coterminals. Okay? All right, let's do more practice. If I wasn't doing a video, I would have some of you guys get up and do these with me, but here we go. All right, now we're going to do negative 80. Well, negative 80 is still a clockwise rotation, but I'm 10 short of 90, so I'm going to do this here. There we go. And it's rotating that direction. And I'm going to say that this is a quadrant 4 angle and a positive coterminal. I'm going to start abbreviating, and a negative coterminal, and an expression for all. So a positive coterminal, right, is going to be rotating counterclockwise. And if I go this direction, it'd be 270 plus 10, right, which would be 280 degrees. And if I want a negative coterminal, what am I going to do? I'm going to take negative 80 and add negative 360, right, because that would be going around again. So negative 360 minus 80, and I get negative 440. And an expression for all of them would be, I start with my angle negative 80 degrees plus 360 degrees n, an element of the integer set. Now, I've often had students ask me, do I have to write this every time? Well, yes, because when you're communicating mathematics, you need to tell people that what you're defining n as when you use it. Okay? All right, good. Now we are going to go positive, our first positive angle here. Okay, so it's 455. So I'm going to put my angle in standard position by my initial side being on the positive x-axis. And then I'm going to rotate in the positive direction now. Now, 455 means that I'm going to go around at least once, which is 360. And if you were to subtract 360 from 455, you're going to get 95. So we're going to go 95 more, which is 5 degrees beyond the vertical here. So we're going to go to here. Okay. So here we go. We're going to say this is a quadrant 2 angle. And if I want a positive coterminal, a negative coterminal, and an expression for all coterminals, what would we say? Well, a positive coterminal would be, instead of going all the way around and then 95 more, I could just say I could start on this initial side and rotate only 95. So that'll work, right? So 95 is a good one. And then I want a negative coterminal. Well, that would just be, if I were to rotate in a clockwise direction, that would almost be 270. Except how short am I? Well, I'm 5 degrees short. So it would be negative 265. All right. And then if I want an expression for all of them, I would say 455 degrees plus 360 degrees times n, and an element of the integer set. Okay? I hope you're getting the hang of it. All right. 530 degrees. Here we go. We put our angle in standard position by the initial side being on the positive x-axis. Now this is a positive angle, so we're going to rotate counterclockwise. So this will be 360. Now, how do I figure out how much further I go? I take 530 and I subtract 360, and I'm going to go 170 more. Okay, so that's going to be 10 short of 180. So there it is. I'm estimating. So here we go, 10 short of 180. And this is a quadrant 2 angle again. A positive coterminal, a negative coterminal, and an expression for all of them. Now, so a positive coterminal, I could start on this initial side and rotate to the terminal side here, and that would just be 170 degrees, which we just figured out. A negative coterminal would be if I rotated in the clockwise direction, ending on the terminal side. So I'd go 180 plus 10 more, which would be negative 190. And if I want an expression for all coterminals, it would be 530 degrees plus 360 degrees times n, an element of the integer set. Okay. Negative 340. So we're going to start in standard position. Initial side on the positive x-axis. And 340 means I'm not going all the way around, because all the way around is 360 degrees. I'm 20 degrees short. So here we go. All right. So let's talk about what kind of angle, what kind of angle this is. This is a quadrant 1 angle, because my terminal side is in quadrant 1. A positive coterminal, a negative coterminal, and an expression for all coterminals. A positive coterminal is going to be, I stopped 20 short of 360, so I'm going to say 20 degrees. And if I wanted yeah, I rotated the right direction for negative. I just had a, an elderly moment there. Yes, I rotated the right direction. So positive would be from this side to this side. That's 20 degrees. All right, if I wanted a negative one, I'd have to go all the way around and then 340 more, wouldn't I? Right? So I'd have to go negative 360 plus negative 340. And I get negative 700. And an expression for all the coterminals would be negative 340, because that's where I'm starting, plus 360 degrees times n, an element of the integer set. Okay, more practice, because practice makes us better. 800 degrees. Well, our angles are getting bigger. Here we go. Positive x-axis is our initial side. Now, 800. Well, twice around is 360 times 2. So, we're going to have, this is a positive rotation, so we're going to go counterclockwise. 1, 2. So that's 720, but I have to go to 800. 720 and 800. The difference would be 80, right? So I'm going to be 20 degrees short here. So I'm going to have to go all the way around to here. You are getting very sleepy, right, as we see those revolutions. All right, so this is a quadrant 1 angle. And we're going to say a positive coterminal, a negative coterminal, and an expression for all of them. So positive one, I think it's going to be 80, right, because I can choose to start and stop here, so that would be 80 degrees. A negative coterminal could just be going around once in the clockwise direction, so I could go this direction and then end at this side here, this terminal side. So it would be 80 less than 360, so it would be negative 280. And an expression for all of them would be 800 degrees plus 360 degrees and an element of the integer set. All right, negative 1,000. Wow, okay, well, here we go. Negative 1,000, we're going to start in our standard position. Now, what's 3 times around? 360 times 3, if I do a quick calculation here, is 1,080. So it's not quite 3 times around, okay? But it is at least 2 times around. In the negative direction. So I'm going to go this direction. I'm going to go down because that's negative first. So here we go. Once is 360. Twice is negative 720. And then I have to do 1,000 minus 720 to figure how much I have left, which is 280. So 280 would be 90, 180, 270. So I have to stop 10 degrees short of here. That line's not very straight, but oh well. So here we go. I'm going to go around and I'm going to end right here. All right. So this is also a quadrant one angle. Positive coterminal, negative coterminal, and an expression for all of them. Okay, so a positive coterminal could be that I start at this initial side, end at this terminal side. And if I went 280, I went 10 beyond here. So this would be 80 degrees in the positive rotation direction. A negative coterminal could just be starting at this initial side and ending here, which would be negative 280 degrees. And then an expression for all of them could be negative 1,000 degrees plus 360 degrees times n, an element of the integer set. Good. All right, so let's do some other ones here. 180. Well, this one is a special one. It's a positive rotation, but it's going to be one of those straight angles. So right here is 180 because I do a counterclockwise rotation and end on one of the axes. So this is a quadrantal angle. Right? So if I were to ask about the quadrant, you would say it doesn't apply, right? In a positive coterminal, a negative coterminal, and an expression for all coterminals. All right, so a positive coterminal would be if I'd have to go around more than once, right? So this would be a positive 180. So what do? I have to go 360 degrees more to hit that terminal side again. So that'll be 180 plus 360, which is 540 degrees. And then it's a real easy negative coterminal because I could start here and end here. And that'd be negative 180 degrees because I'm rotating clockwise. And an expression for all of them would be 180 degrees plus 360 degrees n, an element of the integer set. All right, now that's a quadrantal, and it's an angle without a quadrant, so we call them quadrantals. All right, negative 270 degrees. Also a quadrantal, starting on my positive x-axis, and then I'm going to go negative 270. So I'm going to end up here. Whoops. You get the point there. So we're going to start here and rotate this direction. My arrow looks a little bit weird. Okay. So this is also a quadrantal angle. A positive coterminal, a negative coterminal, and an expression for all. So a positive coterminal, I could say, starts here and ends here, which would be 90 degrees. A negative coterminal would have to go all the way around and hit it one more time. So that would be 270 plus 360 in the negative direction, which would be a negative 630 degrees. And then I could do the expression as 270 plus 360 degrees n, an element of the integer set. All right, so we can have all sorts of, the circular rotations. We can have simple ones. We can go, positive. We can go negative, and all sorts of angles of rotation. So we've introduced some interesting new vocabulary, and not difficult. A little bit of fun, a little bit easy math, in my opinion. The other thing we need to talk about today are arcs. Okay, now back in geometry, there was a formula for you to be able to find the length of an arc. And an arc is a portion of the perimeter or the circumference. We call the circumference the special name of the perimeter of a circle, okay? So, and for arcs, we use for lengths of arcs, we use the letter S. So the length of an arc, okay? And the formula is, and this is what I like to say, the arc length is to the angle, the central angle that intercepts it, as all the way around. So what's all the way around? Because arc length is just a portion of the circumference. The circumference is 2 pi r, is to all the way around in a circle, which is 360 degrees. So your arc length, your portion of your arc length, which is, I want to use a color pen here. This right here, this arc length is a ratio or a portion of the circle's circumference. And I would say that portion is to the portion of the angle of 360, right? So this is all the way around. 2 pi r is the entire length of the circumference. And 360 is the entire circular angle, okay? And we just do a simple ratio. So if I want to find the length of the arc, which is the pink color here, I'm going to say S is to the part of the theta that it crosses, which is 300. So I'm going to say S is to 300 as 2 pi r, and r is 12, is to 360. Right? So all the way around is to all the way around, as part of the way around is to part of the way around. That's the way I think of it, okay? Now to solve this equation, I'm going to cross multiply, and so I'm going to get 360 degrees times S equals 2 pi times 12 times 300. And so I get S equals 2 pi times 12 times 300 all over 360 degrees. And I'm going to drop the degrees because I might think that's a 0. So I'm going to leave it 360. Now, I like to do this thing where I reduce instead of multiplying it all out, okay? So first things first is I'm going to get rid of this 0 because I can if I divide everything by 10, right? And then I know 12 goes into 36 3 times. And I know 3 goes into 30 10 times. So I'm just reducing. And so then I'm going to get S equals 2 times 10, which is 20 pi. And that's going to be miles, right? Because those are my units. And that's an exact answer. I don't have a decimal here. So let's see if that makes sense visually. Okay? Does it make sense that I have a pretty lengthy arc length with a big angle? I think so. So let's try another one. Okay, so if I were to try this one, I'm trying to find this arc length. So what's the central angle that intercepts that arc length? Well, it's 90 degrees. So I'm going to say S is to the angle intercepted, which is 90 degrees, as all the way around, which is 2 pi times r, in this case is 13, divided by all the way around as far as degrees, right? So to solve for S, again, I'm going to cross multiply, and I'm going to get 360 degrees times S equals, I'm going to drop the degrees now, if that's all right. 360S equals 2 pi times 13 times 90, and I get S equals 2 pi times 13 times 90 over 360. Well, this is easier to cancel, I think, because 90 goes into 360 4 times. And 2 goes into 2 once, and 2 goes into 4 twice. And so this this arc length becomes 13 pi over 2 yards. Okay. Here you go. Now I want this arc length. So using the arc length formula, I'm going to say this arc length, this pink one, S, is to the angle that's intercepted by 315 equals 2 pi r, which is times 7 over 360, right? So all the way around is to all the way around as part is to part. Okay, so now we're going to cross multiply, and we're going to get 360 S equals 2 pi times 7 times 315, and then S equals 2 pi times 7 times 315 all over 360. And if we reduce this, let's see what happens. 2 goes into, well, hold on, 315, I think 45 is the number I want, right? 45 goes into 315 7 times. 45 goes into 360 8 times. And if you don't believe me, we can pull the calculator out here. 315 divided by 45 is equal to 7. Yeah, that works. Okay, and then 2 goes into 8 4 times. So this is going to be 49 pi over 4 yards. Okay, let's do a couple more. Here's my arc length that I'm looking for. This is the S. So we're going to say S is to the arc length 315 as 2 pi times 8 is to 360. So we multiply 360. S equals 2 pi times 8 times 315. And S equals 2 pi times 8 times 315 over 360. And we did this just a second ago, so we know 45 goes into that 7 times, 45 goes into this 8 times, and then this 8 and this 8 cancel, and we're left with just 14 pi. And the units are miles here. All right, sometimes we're not given a picture, but that doesn't mean we can't do it. Okay, so let's try that. I'm given r and theta, so my equation is S is to theta as 2 pi r, oops, I put S here, sorry. S, 2 pi r is to 360 degrees. Okay, now what was I given? I was given r and theta, so I could solve for S. So we can say S is to 120. You see, it just feels a little bit different, but the process is the same. 2 pi times 10 all over 360. Cross multiplying, we get 360S equals 2 pi times 10 times 120. And then I get S equals 2 pi times 10 times 120 all over 360. And if I want to reduce that, I can say that 120 goes into 360 3 times. And then I get, what is that, 20 pi over 3? 20 pi over 3 kilometers. Yep, there we go. There's our answer. Next one. Same situation. I'm going to just plug into this formula here. So I'm going to say S is to 315 as 2 pi times 6 is to 360. Cross multiplying, I get 360. S equals 2 pi times 6 times 315. Dividing by 360, I get 2 pi times 6 times 315 all over 360, and just remembering that 45 goes into 315 7 times, 45 goes into 360 8 times, 2 goes into 8 4 times, 2 goes into 6 3 times, and then this reduces by 2, and then I get, it looks like 21 pi over 2. And again, my units are kilometers. Those are some big circles in kilometers. Almost like they're crop circles or something, right? Well, all right. You guys have a great rest of your day. And I look forward to talking to you in my next video. Have a great one. Thanks.